The periodic table is a way of organizing the element based on their atomic number, chemical properties, and physical properties. The elements are arranged in rows called period and columns called groups. There are 18 groups in periodic table, but only 8 of them are called main groups. The main groups are numbered from 1 to 8, from 1A to 8A, and they contain the most common and familiar elements such as hydrogen, oxygen, carbon, nitrogen, etc. The main groups have some general trends and patterns that can help us predict the behavior and characteristics of the elements. For example, the element in group 1 or 1A are called alkyl metals, and they are very reactive with water, while the element in group 18 or 8A are called noble gases, and they are very stable and inert. In this lesson, we will learn more about the main groups in the periodic table, their names, their properties, and their example. We will also see how the main groups relate to the electron configuration of the elements and how they form different types of chemical bond. By the end of this lesson, you will be able to identify the main groups in the periodic table and describe their feature and function. And we will focus on 3 groups: Group 1A, which is called alkyl metals; Group 17 or 7A, which is called halogens; and the Group 18, which are the inert gas. So first, the alkyl metals. They are located on the left side of the modern periodic table, and they in the first group of S block, which goes by the name 1A. So first, the physical properties of the alkyl metals. They are good conductor of heat and electricity. All of them are in solid state, and they have metallic luster. They shine. Most of them have low density, like lithium, sodium, and potassium. Their density is less than the density of water, so they float on top of the water. Rubidium and cesium sink in the water because they has high density than density of water. So as you see here, the lithium, sodium, and potassium has density less than the density of water, but rubidium and cesium, the density are more than density of water. Then the chemical properties of alkyl metals. First, they are monovalent element. Monovalent because they have 1 electrons in their outermost energy level, like lithium, sodium. The outermost shell have 1 electrons, so they go by the name monovalent. They tend to lose their valency of the outermost electrons and form a positive ion, carry 1 positive charge. They're very reactive, so they kept under the surface of kerosene or paraffin oil. As we discussed, that the metallic property increase in group from up to bottom, so their chemical activity increase as their atomic size increase, where the cesium is the most reactive of them because it has the biggest size atom, so that it enable him to lose its outermost energy level, enable him to lose the outermost electrons easily. They named alkyl metal. Why? Because they react with water, forming alkaline solution. So the group 1A goes by the name alkyl metal because they react with water, forming alkaline solution. So both sodium and potassium react with water, and hydrogen gas evolve, which burn with a pop sound. And the reaction of potassium is stronger than sodium because the potassium follow the sodium, so the potassium is more reactive than sodium. So because sodium is more reactive than sodium, because the potassium has bigger atomic size than sodium. So why sodium is kept under the surface of kerosene? To prevent from reaction with moist air, as its active metal. So because when we put sodium in water, it's instantly reacting and the hydrogen gas evolve, which burn with a pop sound. So we keep them under the kerosene to prevent them from reacting from the air. Sodium fires are not put with water because sodium easily reacts with water and the hydrogen gas evolve, which burn with a pop sound. So sodium fires are not put off with water because sodium react instantly with water and hydrogen gas evolve, which burn with a pop sound. So why lithium isn't kept under the surface of kerosene? Because lithium has low density than kerosene, so it floats on top of the kerosene. Because it floats on the surface of kerosene and burns, so we keep them under the bare paraffin oil. So lithium kept under the paraffin oil. Second, the halogens group. They are the group located in the left side of the periodic table in group 17 or 7A in B block. The physical property of the halogens. Their physical state are graduated from the gas state like fluorine and chlorine, liquid state like bromine, solid state like iodine. And all of them are bad conductors of heat and electricity. The chemical properties of halogens. They also monovalent because they have 7 electrons in their outermost energy level. And they gain 1 electron during chemical reaction to convert them into negative ion having 1 negative charge. And they exist in the diatomic molecule. Di means 2. So the halogens exist in diatomic molecules, so each molecule contains 2 atoms. Like chlorine, fluorine, iodine. Each molecule contains 2 atoms. They are active metal, and so they don't exist in nature in elementary state, but they found combining with other element forming chemical compound, except for astatine, which is prepared artificially. So the only halogens not exist in nature and prepared artificially is astatine, while all the other halogens, because they are very active, we can't find them pure or elementary state in nature. We find them reacted or forming bond with other elements. They react with metal, forming salt, and so they goes by the name halogens. So the name halogens because they react with metal forming salt, like chlorine react with sodium forming table salt, sodium chloride. And each element replaces the element below in its salt solution. Why? As we mentioned that in the groups which start by the non-metal, the non-metallic property decreases by increasing the atomic number. So each element is more reactive than the element below, and so that it reacts with the metal in the salt solution and replace it. So we have chlorine reacting with potassium bromide. So the chlorine is more reactive than the bromide because the chlorine is above the bromine. So it replaces the bromine in the salt solution, forming a potassium chloride and the bromine element. So also the bromine is more reactive than iodine because the bromine is above the iodine, so it's more reactive than it. and that's why it replaces the iodine in its solution. But although that the fluorine is the first element in the halogens, and that makes him the most reactive, but it prefers to react with the water than the solution, than the positive part in the salt. So it will react with the water, leaving the salt intact, and that it can't replace any element. So although fluorine is the most active, but it doesn't replace other halogens in their salt because it reacts with water, which the salt dissolves in. And we use this to, if we need to extract halogens metals, in a solution, we add a fluorine. So the fluorine will react with the water and precipitate the salt. Now we'll just see some properties of element and their uses. So first, sodium in a liquid state. We know that sodium is metal, so it has a high conductivity of heat, and the conductivity increases in liquid state. So we use it in the reactor, in a nuclear reactor, to transform the heat from inside the reactor to the outside of the reactor. So sodium in a liquid state, because it's a good conductor of heat, we use to transferring heat from inside the nuclear reactor to outside. The radioactive cobalt-60, it's used in the food preservation because it radiates gamma rays. Gamma rays kills bacteria and viruses, so it prevents the reproduction of microbial cell, but we use it in small quantities, so it kills the microbes and don't harm the humans. The silicon, we use silicon to make the CPUs or the transistors in the electronic devices, such as mobiles, phones, CPUs in the computers and laptops. And that's because the conductivity of the silicon depends on its temperature. So sometimes when you use your phone or your laptop and it gets too hot, it's actually shut down, because as the temperature of silicon is low, the silicon acts as a conductive of electricity, and the electrons flow through the silicon. And when it reaches a certain temperature, the silicon loses its conductivity, and then the device shut down. So silicon slides are used in the manufacture of electronic devices, such as computer and transistor, because it's a semi-conductor of electricity. Its ability to conduct electricity depends on its temperature. And finally, the liquid nitrogen. It's used in the preservation of cornea of the eye due to the decrease its boiling point, negative 196 degrees Celsius. Last group will be the inert gas group. They are located in the right side of the model periodic table, and the element of 0 group in the block B. And all of them exist in gaseous state. And their valency equals 0 because they have 8 electrons in their outermost energy level. All of them end with 8 except helium, which ends with 2 electrons. The outermost energy level contains 8 electrons, except helium, which contains only 2 electrons. They are inactive elements, so they don't react with other elements under normal condition. They exist in the form of monoatomic molecules. So the halogens, if we try to type or write any inert gas, we type neon, we type helium, 1 atom, because it's stable and don't form chemical bond.